I got loyalty, got royalty inside my DNA.
So we'll start, and then we can keep talking about F#.
Yeah.
So hello everyone. Welcome to PL Talk. Today is a special, very experimental treat. So, so for people who don't know, PL Talk is a weekly-ish live stream. It started last summer sometime with Hong Yi-Hu and me. Hong Yi is a co-host. He cannot be here today. He is a security engineer, and sometimes security engineers have to do some security things. But I am here. So I'm Jean. I am the founder and CEO of a company called Akita Software. What we do is API tooling. I think it used to be harder to explain this, but we've essentially turned a lot of what you would normally expect, like software analysis tooling, to be upside down. So we infer API models, we infer API specs, we infer properties about what your software does by looking at API traffic, and then we tell you things, like we tell you what regressions matter, we tell you other things. And I'm really excited to have Thomas here today, because I have been very jealous of him ever since I knew about him. Thomas used to work with Don Simon. Maybe you still work with Don Simon?
If hanging out in the park counts as
working. I recently realized Don Simon was on Twitter and followed me, which is very embarrassing because I occasionally tweet about how I'm very obsessed with Don Simon. So I had to go and review those tweets. But
next time I see him, I'll tell him that you're not creepy.
Yeah, no, I just, well, F# is like, I think it's the best language because it's everything you would want. It's a really nice, strongly typed, statically typed language, but it has overloading done right. And it's on .NET. So you have all the libraries, but I've been existing in a non.NET world for most of my life, except for the summer I got to program in F#. So my life is mostly very sad. But
there was a long period when F# was Microsoft only, but now with the move to .NET Core, it actually reliably runs everywhere.
Yeah. But yeah, so more about Thomas. We're not talking about Don Simon today. We're going to talk about philosophy of programming. So it seems like you've gotten into some pretty interesting, abstract, very this is how we should think about the world, view the world, think about programming kind of ideas, which I think it'll be very interesting to talk about today. So I'll let you. So I guess I should properly introduce you. So Thomas is he was a star PhD student. He got to work with Don Simon. How can you be more star than that? But they did some really nice work on the F# type providers. This is probably the work I'm most jealous of in my entire life, because essentially you can load semi-structured data into F# and get type checking out of it, which is what anyone would want out of life. But this idea of taking chaos and loading it into a system that has order really stuck with me ever since I saw Don's demo. And then Thomas had a really nice set of papers on data visualization, which was the reason I reached out to have him speak on here. But Thomas is like, look, I'm over that. I'm onto cooler stuff now. So you can talk about what the cooler stuff is that we're going to talk about today.
Yeah, well, I mean, I suggested philosophy of science because it's a topic that nobody wants to hear about, and it's something I'm very excited about. So I've sort of misused. How do I pronounce your first name correctly?
Oh, Jean. Yeah.
Jean. I misused Jean's invitation to do this, but I think it is sort of. It is. I mean, the way I think about it is a sort of fairly practical question about what kind of computer science should we really be doing. So you said you were interested in how I got into this.
Yeah, I think so. I think your whole path is very interesting because first of all, you have this very jealousy inducing, very practical background. But then, I think I hadn't kept in touch with how you're very into this philosophy of programming now. So yeah, talking about all of that would be great.
Yeah, I mean, I think that for me, the sort of interesting experience really was doing practical F# programming, which involved work on, at the time, it was a lot of work with sort of data processing because F# just got these type providers. which is a nice way of integrating external data into a statically typed programming language. And I was doing some work on that, and at the same time I was doing more theoretical work on my PhD, which really was about sort of type systems and defining some formal calculi and things like that.
Yeah, someone in the chat already asked, is today the day we're going to hear about co-effects, but it sounds like maybe only a small amount. I was also very impressed with the co-effects work you did with Dominic.
Yeah, I mean, co-effects is, yeah, that's the work I did in my PhD, and that's basically it's sort of, I mean, the selling point is effect systems in programming languages tell you what your programming language does to or what your programs do to the world. Co-effects tell you what your program requires from the world or from the environment. But that was a lot more theoretical. And in a lot of these theoretical computer science papers, we say there's like an introduction section which really highlights some important problem that people are facing when they program, like how do you manage resources, or how do you sort of make your program run in different environments, on phones, web, and so on. And that's like a nice introduction. And then the rest of the paper starts with a bunch of equations and some proofs about these equations. So, I mean, how does this relate? What's the connection between the introduction and the rest of the paper?
Yeah.
And a lot of the theoretical work, I mean, some of it inspires practical programming language implementation, but then none of the proofs will really hold anymore.
Yeah, I think that's also one of the major criticisms of our entire field. And so I think like one reason I usually try to stay away from talking about philosophy of programming is like most of like that stuff is very heavily criticized for having no bearing on reality. But something I really like about the way you think about it is you're like what you're thinking about is precisely how does this theory relate to reality?
Well, I mean, that's exactly sort of how I got interested in philosophy of science, because that's all about how science actually works.
Mm-hmm.
And the sort of classic works in philosophy of science, they're always about, well, I mean, the sort of famous works are trying to sort of explain the scientific method. So, for example, Popper's idea is that scientists propose theories and those should be falsifiable. And a true scientist never confirms anything. A true scientist can only disprove a theory by designing an experiment that sort of makes it break.
Yeah.
That's not really what computer scientists do. But the funny thing is, it's also not what real scientists do. And it just turns out that science is a lot more messy and a lot more complicated. So, I mean, that's maybe a good sign for computer science as well, because I think the way, say, these sort of theoretical works actually influence practical aspects is just a lot more complicated and sort of less clear and less direct.
So when you talk about philosophy of programming, what do you mean? And what part of that are you planning to talk about today?
Well, so what I mean is really sort of following in the tradition of philosophy of science, which is trying to understand how science works, and possibly how could it work better, or how it sort of misrepresents its history.
Yeah.
And that's the thing that I'm sort of ready to show today as well.
Yeah. Cool. I think this is also something I think about a lot too, because like the arcs of tech transfer are very sometimes tenuous.
Yeah. I'll have to disappear for 10 seconds because our son is just waking up and I'll just have to transfer him from one bed to another bed. Well, I'll be back in 10 seconds.
Okay, cool. In the meantime, I will field questions from the audience. that you want us to discuss today? What are your thoughts about the gaps between theory and practice? What are your thoughts about what is the theory? What is the practice? Yeah, Kevin said, oh, you're
That's
back.
it.
That's great. That was really 10 seconds.
Yeah, well, I sort of thought this is fine. We'll manage that.
Yeah.
Yeah, so I mean the thing that I guess when we were planning this, Jean mentioned that she always wants to have some demo, and I think that's a great idea. But obviously, when you say, give me some demo to talk about philosophy of science, that's a bit of a challenge. But then I've realized I've done this little fun project recently, which actually fits the description pretty well.
Yeah, I think it's really exciting too, because I feel like whenever I talk about, like the romance of old school programming, it's always the Commodore 64.
Yeah, so sort of a little bit of context for this is that, and I mean, should we just switch to screen share and show
Yeah,
it
let's
now?
just switch to screen share and we can talk through it.
I'll just share my screen and we'll see what we find here. So I've got a local version of this running here, but it's an interactive essay which we can send you a link later on.
Yeah, I'll send it right now.
Perfect, thanks. And the idea is it's trying to give you a bit of experience of what programming with Commodore 64 was like. And a little bit of a disclaimer is that I've never actually had Commodore 64. So all my experience comes from playing with it in I think Seattle has this really nice live computer history museum where you can go and play with random old things. So I did play with it there a little bit. And you can obviously sort of play with various emulators online. But the reason for doing this is sort of not just because Commodore is a sort of fun bit of history, but because I think it shows one aspect of programming that we are sort of forgetting about when we talk about programming. We always talk about programming languages, and the language here is just basic, so you can run print hello world, and that's it. But what's sort of interesting about this is that I mean, I always find it really interesting how you interact with the system. So here you can do things like, say, print hi, and it prints hi. So it behaves like a REPL. But the other thing that that it does is that you can start with line numbers, and then it doesn't run your code. It just remembers that this is a line in your program, and you can list that. So now I've got a program with one line, and you can do your obvious program that prints hello world forever. If I run it, it just keeps printing. So the reason why I think this is interesting is that it has this sort of very, very simple interaction model where you just type and that's all there is. But the typing works in part as a REPL, and in part it works as a editor. And you can sort of edit your code by going editing, or you can edit a line by just sort of replacing it with a different one. So now I've got a different program and I can run it. So this whole sort of interaction is really why I have done this and why I'm trying to show you how that works. And I'm going to scroll down to a sort of more interesting example. So this is a famous basic one-liner that generates a maze. just by printing slashes and backslashes in sort of random order. So that's still just basically a loop. But as you sort of, so I'm going to scroll down a little bit further, all the way. I'm actually just going to run all the way to the end. So the whole thing that this tutorial implements is this little game where you have a bouncing ball and you have to hit it, and if I don't do it, then that's a game over. And as I was working on this, I did sort of start by writing the game step by step, and there's quite a few sort of interesting aspects to this. For example, the fact that you have this. I mean, people always make fun of BASIC because it has these line numbers, but there's actually a lot of things that this makes possible. So here in my case, on line 2500, this is where the moving of the pedal on the left starts. And at the end of the section 2500, it just jumps to 2000, which is where the ball movement happens as well. And one thing I found amazing is how sort of flexible this line-oriented environment is, because I can just I can edit the go-to that's right here, and make it jump to 2500, which is after the handling of the ball movement, just at the start of the pedal movement. If I do this, now the other funny thing here is that you can run this using run, or you can just say go to any place in the program. So you have this sort of addressability where from the REPL you can just jump anywhere you want. So I can jump straight to my pedal movement, and now I've got only a part of the program. So I've just got the pedal on the left, but I've eliminated the ball movement. And what I think is, I mean, this is kind of interesting because it gives you this easy way of debugging a half of your program, which I don't think is something you actually really get in modern programming environments, or not that easily. So the point of the demo really, I mean, the point of the demo is to show that if you look at some of these past systems and how you interact with them, you might actually learn some new ideas. And this is something I got to from philosophy of science, because in philosophy of science, a lot of it is sort of inspired by looking at history and analyzing what happened in the past. And one sort of important idea is this idea of scientific paradigms, where at some point the science sort of makes some basic assumptions about how it works, and when that stops working in some sense, people will suddenly sort of switch to a different set of assumptions. And this is something that Dick Gabriel has argued has happened in the world of programming, when people stopped thinking about programming systems, started thinking about languages.
Yeah, this is very related to something I've been thinking about a lot, which is most of the software engineering methodologies we have are around this idea of shrink wrap software. Essentially, you build, then you ship, and then fixing bugs is very expensive, et cetera, et cetera. But I had a really interesting conversation, a really interesting set of conversations on Twitter this week with some people who I believe are here, about how, like the modern development environments are actually much closer to what things were in the Commodore 64. Like before the days of shrink wrap software, like you had no programs that came with the Commodore 64. You had to type everything in, and it was a live interaction always. But like that's where we sort of gone back to, because when software is so much dependent on SaaS, and you know, running other people's code, we're back in a world where some of these older paradigms are actually much more relevant. So some people were saying, you know, like their dream is coding against like, you know, live REPL against like other live SaaS apps, things like that. And so I think this is a really cool reminder that programming was not always this like, you program, like there was a language and then you like package that up. So yeah, that's super cool. Yeah, I didn't think about that this way.
And I mean, if you, it took me like 2 attempts to read Big Gabriel's paper. I think it's called the Structure of Programming Language Revolution.
Oh, interesting. Yeah, so it's like modeled off of Thomas Kuhn.
Exactly. Yeah.
Yeah.
And I see someone mentioned Kuhn in the chat, which is exactly the reference.
Yeah. Somebody else in the chat. Oh, sorry.
Yeah, go ahead.
Somebody else in the chat asked if there's one book to read about the philosophy of programming or the history of programming. What would you recommend?
On history of programming, I mean, there's quite a few books. I think people who are like me, coming from a sort of programming background, would probably like a book called Science of Operations by Mark Priestley, which documents the sort of very early history of programming and how that appeared. And even how the idea of sort of programming language as as a sort of independent entity that can be mathematically studied, how that came to be.
Cool. Yeah, so I really like the things that you've been saying and writing about programming as interaction, programming systems, not programming languages. Yeah, I'd love to just hear more about, you know, how did that start? Like what is the ongoing thinking around it? What are the open questions that you're grappling with?
Well, I mean, I think this was very gradual process. And now it all sounds very clear, but I don't think that was the case a year ago. I think it really is sort of, I mean, even with F#, it's sort of statically typed programming language, and people will always tell you that the benefit of statically typed programming languages is that types will make sure that your program, if it compiles, it doesn't contain certain errors. But a lot of why I actually enjoy writing F# is the sort of live feedback you get from the editor.
Yeah.
And that works based on types, but it's if the sort of type checking before compilation or during compilation wasn't there, that would lose you some of the benefits. But I mean, I would still be quite happy with that. So I think sort of my first step was really sort of, I do think that the editors and the way you interact with the systems, that's just part of the experience. And then as I was looking at various systems that existed in the past, I mean, Smalltalk is an obvious example that everybody has seen at least a demo of.
Yeah.
That's sort of as much knowledge as I have about Smalltalk myself. But you really sort of live in the environment.
Yeah, Lisp scheme.
Yeah, I mean,
yeah.
Lisp. Lisp is something I've been very curious about for a long time, but mainly because there's this thing called Lisp machines, which
I was really
like
obsessed with Lisp.
Us don't know, or have you ever sort of looked into these things?
No, but there were like I remember I learned Lisp in school, and I was shocked that it was such an old language, because I did not believe that it was possibly to efficiently run Lisp before like the 90s. And so then I was like again shocked that there were Lisp machines, and that had been a real thing. And that I think, who was it? It was like Guy Steele or someone had done their undergrad thesis on Lisp machines. So I went to the library in my university and I tried to find that thesis because I, again, could not believe this was a thing.
No, but Um, I think the history of the Lisp machines was that they really just, there was some sort of architectural change in
Yeah.
widely used machines that made it harder to compile and run
Yeah.
Lisp. So they started building their own machines, but then got bundled with the inter-Lisp programming environment. So the machine really just, like, you bought a computer, you started it, and there was Lisp.
Yeah.
Just like with Commodore. Um, and
Yeah.
then you had this sort of Smalltalk like interactive environment where you could sort of, from your program, from your REPL, access anything that existed in the system.
Yeah. Yeah, I think it's a really good observation that, you know, a lot of what people think are specific to modern environments like Jupyter notebooks or something like that. Actually, like that paradigm has been around for a really long time. Yeah, it's
Yeah.
also interesting because I think that when I saw programming systems on your website, I didn't think of REPLs necessarily, because I think a lot of like universities, when they have a programming systems category, they often mean systems programming.
Yeah.
Yeah. So like, how do we program large systems using programming languages,
Yeah.
but still in
Well,
this like
this is
static
really
build ship
sort of
way. Yeah.
shows or proves Dick Gabriel's idea that the very sort of notion of programming systems is something that this sort of paradigm shift to programming languages has erased.
Yeah, I think that's really interesting, because I think also like a lot of these older languages feel super modern. And like I think one reason I was shocked to discover the existence of the Lisp machine was when I was in school, you know, everyone said you have to program in assembly if you want things to be fast. Because I remember like, you know, there's a story of how Russ Cox had rewritten like the front end of like the code search, Google code search, to be in assembly so it was fast enough. And like, you know, people are like, we can't use Java because we can't afford the 50% memory overhead. So like the fact that Smalltalk and Lisp had existed decades ago, like I think people, it really wasn't in their consciousness. Yeah. Very interesting.
So I mean, I was really sort of looking at bits of the history, trying to understand what was going on. And as I was doing that, I was increasingly realizing that these people talk about completely different things than modern computer scientists would.
Yeah, and I also think like, I don't know if this has been something you've dug into, but there really like have been two waves of like academic programming languages research, and I feel like we're kind of we're part of a third wave, but it's an undefined wave from my perspective. Like the first wave was all the system stuff, so like Barbara Liskov and Clue, and like, you know, like Smalltalk. All these languages were made. Wait, are you frozen, or are you just like listening?
I'm listening. I'm
Okay.
watching the chat.
I see. I couldn't tell, but you know, like a lot of these early kind of interactive languages, they're really made for operating systems, and it was a very like programming systems had a different like a different perspective. And then, you know, sometime in the late 70s, I feel like the field got taken over by logicians who needed a place to go. And so, you know, like John Gutag left the field, Barbara Liskov left the field, and then it's been all type systems since then. But now it's something else. Like maybe it's many other things. And I think, yeah, I think I now see your point of view, that I think taking like a more principled view on like what paradigms are we really thinking about here is it's a good time for that.
Yeah, I mean, I think that was sort of what I got from all this armchair philosophy.
Yeah. Interesting.
The sort of idea that there maybe was very different way of thinking about programming, and that it actually would have interesting things to say about what we do today.
So like, do you have specific goals here? Like, you know, is there a goal to like recognize or learn from the past paradigms, or is it just like an exploration to better understand the world?
Well, I mean, the truth is I just like doing this.
Yeah. Very
And if
interesting.
I occasionally manage to publish a paper that's inspired by it, then that's all I need to do, right? But no, I mean, there is a bit of a objective, because I do think we should be thinking and writing more about programming systems. And I mean, I think there's a very good reason why the programming languages paradigm has won, which is that it's something you can just work with more easily using mathematical methods.
And yeah, you can
And
have an
someone,
evaluation section.
yeah. I mean, someone mentioned in the comments that computer science is really more like a mathematics, and I think that's sadly true, or that's sort of how we end it. But um, yeah, so with sort of formal methods, you can study programming languages, but how do you study programming systems?
Yeah, I don't know if you saw this blog post I wrote a bunch of months ago about what's the role of developer experience in programming languages research.
Mm,
But that's something I've been thinking about a lot since I don't officially do research these days. But a lot of the work I've been doing is really studying like programmer interactions and like what the
mm,
programmer experience is going to be, which is, I think, is very tied to this idea of programming systems you're talking about. And there's a whole section of that blog post where I talk about like the evaluations sections of programming languages papers are kind of inverted to emphasize this, because like you can either evaluate the proofs or you can evaluate the performance benchmarks, but usually like the
yeah,
part that's actually the developer experience shows up in like the introduction or the motivating example. There's
yeah.
no studies to back it up. There's not really like an extended discussion of it. It's not really part of the program committee discussion of the papers at all.
Mm,
um
mm.
and so yeah, I'm curious, like, have you thought about like what a world where we're actually, where like developer experience or these developer interactions are actually first class, like how we would think about it in a principled way.
Yeah. Well, I mean, there's a couple of people who do actually look at um, sort of programming systems from the human computer interaction perspective. Um,
um oh, there's a
so
quick audience question that's related. What is
yeah,
a programming system here?
what is a programming system? I think it's really the sort of thing you interact with when when you program. So
Mm,
in most things that you program with today, I would say it's the sort of language together with the editor, together with the REPL, together with the package management as well.
interesting, yeah.
Basically, all you have to do to produce a program. Um, in in the world of JavaScript, I mean, so the Commodore emulator. I mean, there was a comment in the chat how we managed to get so quickly from F# to Commodore and philosophy. Um, and at least one connection between Commodore and F# is that my demo was all implemented in F#. Um, so I'm going to share screen here as well. So this was running locally, and I think, I mean, this is a good example of what is a programming system, because I've got my code which is all written in F#, and this was hacked together as quickly as possible. So there's nothing elegant about this, but it's got some tokenizer, some parser that parses the code you type into commands like print, where you print an expression, um, and then there's some interpreter, and to sort of show the programming experience, somewhere at the bottom, I've got a bit of code that simulates what happens when you're entering program. So when I was here and I sort of clicked show me, it entered the code and then it started to run. And if I change this to 10 in my F# code, somewhere here in the background, this triggers this is running through Webpack, and Webpack has extensibility mechanisms, and there's an F# to JavaScript compiler that sort of plugs into that. So Webpack notices that I've changed the file, and it invokes the F# to JavaScript compiler, and then my page reloads, and now I can show you things much faster than before. And the answer to what is a programming system, I think, is it's this code and this editor, the code in the language, but it's also this thing running in the background that makes sure that when I edit the code, it gets updated, and it's some little thing that's running in the browser, watching for the recompilation to happen. And in this example, it's sort of you have these three separate windows. You have your code editor, command line, and the browser. But in Smalltalk, this was just sort of all together in the same environment. And I think we've just really sort of got used to this split. So people don't even think you could sort of partition the tools differently.
Yeah, cool. So back to the question of how do we build evaluations to encourage people to work on this? How do we, like, what's our notion of what's good?
Yeah, I mean the question of evaluation is sort of tricky because there's established things that people do in human computer interaction research. I mean, you can do some user studies trying to show how certain feature makes or lets people do things more efficiently, and that's sort of useful if you're but it's kind of like all this research on machine learning that tweaks something by 0.5%, and that's a huge improvement.
Yeah, I feel
And
like the user studies, like, I feel like they're limited in scope because you have to be able to take people off the street or undergraduates or whatever, kind of introduce them to a very complex system. And so if you're trying to prove anything besides onboarding to your tool is very fast, it's very hard.
Yeah, I mean I completely agree that this is very limited, and you can sort of see how a lot of work that's done on education, for example, or a lot of like studies that happen in this way, they're really like we did this to our undergrads and they
Yeah.
survived.
Yeah, I guess sometimes they can say, like, we taught our undergrads for a whole semester and look, they're still there. Just
Yeah,
like, what does
yeah.
this prove?
And they said they liked the course, but of course the person who was
Yeah,
teaching it was probably very enthusiastic that they get to use their
yeah.
tool.
I guess to be fair, a lot of psychology research isn't better because, like, well, I don't know if this is true where you were an undergraduate, but they would say pay $5, we'll pay you $5, we'll give you an ice cream if you come sit in this room, and then if you
Yeah,
say the right thing, they'll give you 2 ice creams. And so,
yeah.
like,
And it's something even in the human computer interaction research, um, I feel like people are slowly moving away from this, and they're really sort of focusing more on qualitative evaluation, where they
yeah,
just talk with a few people and sort of document how they reacted to the tool.
right.
And I think that's more relevant, that's more sort of interesting, that's the kind of thing I would like to read,
Yeah.
but it just sort of feels much less scientific.
Yeah, well, one of the points I made in this blog post was that user research is, like, it can be very principled. There's, like, few things you can do, like always ask the same questions, always ask them in the same order, control for variables when you're asking questions. And I think that that's something I would love to see more of in this programming system style of work, because I think that, like, for my PhD, I made a programming language, and when I was on the job market, the questions I would get were, did you do user studies? And I was just like, oh, well, you cannot user study a programming language.
Yeah.
Yeah. So someone in the audience asks, why does the evaluation need to be scientific?
Well, I mean, that's just the practical concern of universities, right? So
Well,
if
there are
you're
also non-sciences in the university.
yeah, so if you're doing programming languages research at a university, then you want to publish in good conferences. But the good conferences are the ones that sort of publish the most rigorous, most scientific research.
Yeah.
And that just is sort of the most mathematical one, or the sort of performance things you can do fairly rigorously. So this is something that's just sort of very unfortunate. And I mean, I think if you're outside of a university environment, then you can work a lot more freely. But then you have other concerns, like actually producing things that people will buy.
Yeah. And I also feel like computer science is always trying to establish that we're science. So we really have to be scientific. Otherwise, it'll just be called computers.
Yeah, I mean, I think it's really a shame that the sort of um, the applied and the academic work aren't talking to each other more often.
Yeah. Yeah, I think the goals are also just very different, because if you're like, if if the academic work is evaluating itself on proofs and certain benchmarks, like for the really applied stuff, you don't get to that level, that scale of benchmark for many years a lot of the
Mm.
time. Yeah, so there's an interesting audience question. What type of programming systems do you think are underexplored relative to the status quo?
Yeah, I mean, so a lot of the work that you used as a reason to invite me was around sort of programming for non-experts. So I've done some work on um, it's sort of an attempt to make simple data exploration more accessible.
Mm-hmm.
Um, so the motivation is, if you look at the kind
Mm.
of work that journalists do when they work with data, um, they will often try to do it with Excel, and often that will actually be fine. But once they got bigger data set or more tricky questions, suddenly they have to sort of switch completely and learn Python.
Yeah. Oh, yeah. This was the PLDI talk I saw you give in 2016, right? Yeah.
Yeah, and this is really a sort of, there's like a massive gap between Excel and Python.
Yeah.
So I think one interesting sort of space to fill is something in between
Mm-hmm.
here. Um, and um, sort of more specific idea I've been wondering about recently is, could you do something like this if you represented programs not as the source code, but as sort of sequence of interactions with the programming environment?
Oh, this is the whole reason why we're working on API traces, because I felt
Mm,
like source code, it doesn't tell you like anything when it
yeah,
comes to these complex environments. And like, so people are still doing code reviews off of source diffs, which I think
yeah,
is insane. And
yeah, yeah.
so, yeah, like everything we're doing at Akita is like, well, why don't we just capture API request response traces, make that the currency, and
Yeah,
then
yeah.
model that instead. And then I think people are very confused for like the first couple of years, because they're like, where does anything formal methods related come in? And it wasn't
Mm,
until we had Neha Rungta come on PL Talk a couple weeks ago, and she said, look, the big realization we made for how formal methods is going to be big is traditionally you have an expert write a spec, and then you verify that spec, but actually to make this more palatable, you need to invert it and have the verifier generate specs.
mm.
So like these days I'm all about, we should capture interactions, at different levels of abstraction. For us, it's the API, but really like what you want is to capture interactions, and then we should invert how we think about the specs.
Yeah, I mean, I think it's like the thing that people do just sort of so often when they do some data science is that they will write some code using one input as an example.
Yep.
Like in your Jupyter notebook, you will always read some data,
Yep.
and then you fiddle with it and you create a bunch of cells, and then you want to run the whole notebook for different data source,
Yeah, I see. I
or
see.
for
I
10
oh
data.
yeah, yeah. This is a slightly different thing, but this is very interesting. Yeah. I am.
Um, but yeah, I mean, this is a case where like you sort of start from very concrete, and then
Yeah.
you just need some way of sort of saying, turn this into a function.
Yeah. So how does this relate to the like program synthesis by example work from Sumit Galwani for Flashville, for instance? So, you know, for them, it's like what they did was like, all right, you put 2 dates, then we can extrapolate and put all the other dates. You know, is what you're thinking about related to that, or is it something else?
I think it's what they do is sort of clever version of what I'm thinking about.
I see.
But I think you could do much more even without being very clever about it.
I see.
You
Just
could
like
say,
capture and replay.
yeah.
Yeah, have you seen Philip Guo's taco system, where like the premise was scientists do computational work across a variety of different software, and they can't actually reproduce anything because like replay only exists within like individual pieces of software. And so he did this work where it was like let's do replay across, you know, your Python scripts, your like your different things. But yeah, I think that like this idea of like coding as replay is really interesting.
And it's so I haven't seen this, but it definitely sort of sounds like this idea at a bigger level.
Yeah, also related is I spent a couple of years talking a lot to the Julia folks because they were trying to you know, characterize what it is they had built with Julia, and I wasn't really, I was also very confused about how to characterize it, so I handed them off to Jan Vitek. But what they said was really interesting because they're like, look, a lot of the people when they start writing a program using Julia, they don't know what data they have, so they're writing these exploratory programs, and so like you can't ask them for the types because it's not that they're not principled and can't think of the types, they don't know what the types should be. And like often the types are as specific as this is, like, you know, like I don't know what these different matrix categories are, but like Hermitian and like, you know, upper triangular, lower triangular, stuff like that. Like you just don't know until you get the data. But I think this idea of like programming as exploration, which I think maybe you mentioned in one of your blog posts, like I've also come to realize is like a lot of people who think of programming languages as a static thing, you like write it, then you compile it, they like really, they kind of try to really sweep this programming as exploration part under the rug.
And I guess this is something you do all the time when you're using some APIs.
Oh yeah, for sure. It's all like very exploratory. And you know what people tell us is like they don't write the API spec not because they like are necessarily lazy or like it's not important. They don't know what it is sometimes. And so yeah, I think all these topics really like should get more attention. Because I think it says something that like for the first year of Akita, I just really didn't even know what words to use to explain to people how this related to anything in academic literature, because like it just, there were no words for it.
So do you sort of look at the request response that happen as part of a running of some system? And
Yeah, like we look, it's all behavioral, like dynamic. Yeah, and this actually like
sort of try to extract some spec of what's
so like we like model it as sort of like a annotated open API sort of YAML specification where we have endpoints, we have types, and then we're starting to build up things like data formats. Implicit contracts would be a next thing, like how are fields actually related to each other. But yeah, it's like the spec is like this emergent found thing, not something someone wrote.
Yeah. No, that makes a lot of sense.
Yeah. But yeah, this is a space like I would love to see more work on too.
Yeah, I'm just checking what people are saying in the chat.
Yeah, people are saying a lot of stuff. It's very interesting.
There's a comment about, Lambda in Excel. That's going to be interesting.
Oh yeah, what are your thoughts on that? Like, does that connect Python with Excel or no?
I don't think it does. I mean, it just lets you write more complicated. It's a sort of, I think it's a starting point. And there's some video from Popple from Microsoft when they were the partners of the conference, where they show what their thoughts on this are, and they're sort of building more experimental tools for actually sort of let you write these things. But I mean, the thing that is so amazing about Excel is that you really start with concrete. Like you put in your data and then you write your formula, and then if you want to apply it to multiple rows, you drag down.
Yeah. Hmm.
And Lambda just lets you do sort of more regular programming.
Yeah, I
What
see.
I
So
really what I really want is this sort of drag down, but for real programs.
yeah, 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 that makes sense. Hmm.
And that, I mean, I don't think anybody knows how to do this.
And do you think studying the past of programming will give us more ideas? Because I think it's a really good point you made that people just have forgotten like all the first decades of programming.
Yeah, I mean, I think it's for me it was really useful for realizing that these sort of there was a very different way of thinking. And I think understanding that is useful for sort of freeing your thinking a bit.
Yeah, yeah, no, that makes sense. And
And
oh,
this
sorry.
is
No, go on.
no, go on.
Oh, I was just going to bring up an audience question, so you should finish because this is
Okay
could
then.
derail us.
Yeah, I mean there's sort of um this is something that historians of science are sort of s- discussing among themselves as well, because they're the kind of people who I mean in the UK, when you're writing a grant application, until recently you had to write a pathways to impact
Yeah.
section. And then, I mean, programming language people have it quite easy. They'll just say, or we'll put it on GitHub and talk to some people who actually do these things in the industry. But then you talk to historians of science who are sort of studying Newton's alchemy, and they're like, well, I don't know. How is this going to have any impact? Um, but some of the answers for history of science is that it really sort of gives you a more critical perspective and
Mhm.
see the bigger picture. And and sort of more specifically, there's this idea of a thing called complementary science, which is using history by sort of looking at what has been done in the past, what ideas have been abandoned, and see if
Yeah.
we can make them relevant to present time. And
Interesting.
that's kind of exactly what I'm trying to do with this Commodore thing.
Oh, that's cool. Yeah, like all of deep learning too.
Yeah.
um cool. So there are a couple of questions. Someone said drag down for lambda in Excel, isn't that just map? And then somebody else says, and as of this morning you can drag lambdas too. So they want to know your stance on this.
Um, what was the second thing? What can you drag?
Apparently you can drag down lambdas in Excel now too,
Oh
as of this
yeah.
morning.
Um, do you mean to sort of? Well, I'll have to look at what you can do with lambdas.
Wait,
You
someone
can
says no, you
definitely.
can't drag down lambdas. I don't know. Oh, sorry, go
I
on.
wouldn't be surprised if you can just sort of have them in a formula and drag down and apply them to you. You can definitely drag down to apply them across a list, which is
Yeah. That's apparently what you can do. And then somebody else says, isn't dragging lambdas just sort of like mapping, just like applying the same function?
yeah. I mean, it is. It is from the language perspective. It is exactly mapping.
Hmm.
From the user interaction perspective, it's nothing like mapping,
Yeah.
because you
I
always
see.
you do this. You always see your values. You never.
Yeah.
I mean, so one thing that I was trying to do in this project that was mentioned in the chat that I worked on the data visualization called the gamma is I want to be able to write code in a way where I can always give you a preview of what you have,
Yeah.
run things in background. And because I think that's just a lot. If you can sort of write code and see the concrete values you're working with, that's just so much easier than if you have a variable called x and it
Yeah.
represents something.
Yeah, no, that makes sense. And the person who asked the question about the drag down says, drag down seems like an idea from programming applied to Excel. And so, what does it mean to apply drag down back to programming? But I think what you're saying is it's not about programming. It's not about the program itself. It's about how you make the program. Is that accurate?
Yeah, I think it's really sort of focusing on the interaction. And the powerful thing about drag down is, for me, really, you can work with concrete values.
I
So you
see.
sort of fiddle with concrete values,
Yep, yep,
and
yep.
then you do something to reuse that. Um, and maybe to sort of bring it back to programming, it's a bit more like doing some sort of macro recording where you sort of play what you want to do, and then you're able to sort of somehow automatically replay that.
Cool.
And there was this very sort of curious programming system called Pygmalion from like 70s, done in Smalltalk, which was actually doing this in some way. Um, Now the PhD thesis is published somewhere, and you can, most of it is about history of art, but it does have a Smalltalk. What is it? The first Smalltalk 72 appendix, which presumably somebody could actually run if they were able to do that. Yeah, that was trying to do this sort of idea, like you program by manipulating some icons on the screen, and just by this concrete manipulation, you construct even abstract programs.
Well, so we have a couple of minutes left. And I know you have many things that we talked about you want people to take away before we go into the Discord. So I don't know, it's very late for you, but I told Thomas that, if he goes into the Discord, there might be questions for him. So there's a chance you can catch him and ask some questions.
I'll join the Discord afterwards.
Cool. Yeah, thank you. But yeah, as while we have you live though, like I think there are some language designers, tool designers, language enthusiasts, tool enthusiasts in the audience. Like how do you want them to go forth and
Yeah, I mean,
live?
I think so there was a question at the start about a book I would recommend, and I think no, we talked about the sort of science of operations as a specific history of programming book, and I think Thomas Kuhn's History of Structure of Scientific Revolutions is the sort of most interesting philosophy of science thing. But I actually really enjoyed a book by Paul Feyerabend called Against Method, and this was sort of in my second year of my 3-year PhD. So somewhere in the middle of my PhD, when I was like, "Oh, come on, what am I doing here?" And it was sort of very nice, very anarchistic book that says science has no structure. You have to deal with it. You just scientists just somehow are creative and sort of do the thing that makes sense.
I
And I
kind of
think,
agree with that. Yeah.
and I mean, I wouldn't necessarily recommend the book to anyone because I think it might be too crazy for many people. But I think my sort of takeaway is really sort of um, rooted in this. I think doing crazy things like getting back to Commodore Basic or trying to sort of understand this obscure Pygmalion thing, or breaking all the assumptions that people make in programming language research. I think that's the way to go.
Yeah, I mean, I
And
agree.
it's
I
fun.
feel I had a mentor in grad school who said that, his how he operated was he would read a bunch of papers, figure out how everyone's thinking, invert it, and that would be his next area of research. And I really believe in that too. I think, the inversion of everything that's true, including the structure of the revolutions, is where the next revolution happens.
Yeah, I agree.
Well, thank you so much for coming on at such a late night hour, talking about such an interesting thing.
That's all right. This is my favorite time of the day anyway.
Well, yeah, I'm
Thanks,
I'm a
thanks
very
for
night
letting me
person.
talk about something completely different than you originally
Yeah,
intended.
I admit I was like fairly worried because I didn't know how it would go at all, but this was super interesting. And I actually I think about a lot of these topics too. I just like call them different things. So I'm really
Yeah.
glad we talked about this. Cool. So everybody in the chat, I'm going to put a link to the Discord really quickly so that everybody has the ability to join us. Everyone is thanking you a lot, by the way, in the chat. Let me throw a Discord invite link into the chat. Different but kind of the same. Yeah, this is a different but kind of the same, because I mean, like I said, I feel like these are the kind of ideas we really are that underlie every single session, but we don't quite explicitly talk about it. So yeah, thank you everyone. Thank you, Thomas. I'll see everybody in the Discord. Bye.
Peace to the world, let it rotate. Sex, money, murder, our DNA.